Hi everyone. In this video we are going to start on outcome 5. Our very first section looks at simplifying radicals. Now we've seen a few radicals so far in Algebra 2. We've looked at square roots, we've looked at cube roots. In this unit we are going to continue our work with square roots and cube roots, but we are going to extend our knowledge and see a variety of different radicals. Before we jump into some examples, I want to make sure that we're all on the same page as far as vocab goes. So here we have an example of a radical. You'll notice that we have that symbol here, and that symbol is called the radical. There's two pieces that every radical has. It's going to have a number on the outside, which we're using as n. Okay, this n is just going to be a number, kind of like you saw with this 3 in the cube root. And then there's going to be another number inside of the radical. The number that we have on the outside, that n value, is called the index. And the number inside of the radical is called the radicand. Now in today's lesson, we're going to see a variety of these radicals, and we are going to focus on simplifying. Now you'll notice as you look at example 1 here, our radicands can be a mixture of numbers and variables. Whenever we are simplifying these radicals, we are going to divide the exponent by the index. So I'm always going to take the little exponent, which I might have up here. Okay, this would be the exponent. I'm going to take that exponent and divide by the index. Let's go ahead and take a look at a few examples. Okay, example 1 says simplify, and it gives me the square root of 16y to the 4th. Now one thing that I'm noticing right away is that I don't have a little number there on the outside. I don't have an index. Now this is a square root, which is the most common type of radical. Because it's the most common type, we don't put that number on the outside for our index, but it is technically a 2. So anytime you don't see an index, you can assume that it's a 2. Now to simplify, we are going to start with simplifying the number first. So what I need to do here is take the square root of 16. I'm going to start with checking in my calculator, and you might already know the square root of 16, but if you don't, I want to show you how to get that on your calculator. To get the square root in our calculator, we're going to press second, that's the blue button, and then we're going to press x squared. So I have that little square root, and I'm going to type in just the 16. I'm only typing in the number, not the variable. Square root of 16 gives me 4. So far I know the square root of 16 is 4. Now I can't type in this y to the 4th in my calculator, so I'm going to have to do this a little bit by hand. What I'm going to do is take that y to the 4th, and I'm going to divide my exponent, so I'm dividing the 4 by my index. The index in this case was 2. So when I divide 4 by 2, I get 2 left over. So I now have y squared. Once you do that division, so once you divide your exponent by the index, whatever you're left over with is now outside of the square root. Okay, let's take a look here at example 2. This says simplify. Now we have a radical. The index is a 3 this time, and I have 16x to the 10th. So I'm going to start again with my calculator. I want to figure out if the cube root of 16 works out nicely. To get to that cube root, we are going to press math on the left-hand side. And then we're going to go down to number 4, where it gives us a radical with a little 3 out front. I'm going to type in my number, the 16, and it gives me a decimal. Now when we're simplifying here, we want things to be in simplified radical form, so I never want to get a decimal. So here's what we're going to do if you get a decimal in your calculator. We're going to make a factor tree, take the 16 and break it down as far as we can. So I'm going to break 16 into 4 and 4. I know that 4 times 4 would give me 16. Okay, 4 I can continue to break down into 2 and 2. And once I've broken it down, I'm going to cross it off. That 4 is no longer there, it's now just 2 2's. Again, this 4 can break up into 2 2's. So what I have here are 4 2's being multiplied together. I really have 2 times 2 times 2 times 2. Now this is kind of silly, but I think of these radicals like a jail. Everybody wants to get out of jail, right? Jail is horrible, we don't want to be there. But in order to get out of jail, these numbers are going to have to group together. The index, so the 3 here, is going to tell us how many numbers need to group together. My index is a 3, so I'm going to group 3 of the same numbers together. I'm grouping these 2's together. Only like numbers can group together, so if you had like 3 times 2 times 5 times 2, I could not group the 3, 2, and 5 because they're not the same number, so this would not work. They all have to be the same number in order to group together. Now, getting out of jail is kind of tricky. It's a hard job. So what happens is when these 2's group together to try to get out of jail, only one of them is going to make it. 2 of them are going to get caught by the guards, so we just cross them off. This 2 has now escaped from jail, so it is outside of that radical. This little 2 here, he did not have a partner, he didn't have a group, he could not get out of jail, so that 2 is going to stay inside of the radical. Okay, we're going to move on to our exponent. So I had x to the 10th power. Now what I'm trying to do here is take that exponent and divide by the index. So I'm trying to divide 10 by 3. Now 10 won't divide by 3 perfectly. If I try to do that in my calculator, it's going to give me a decimal. But I know that 3 can at least go into 10 a few times. So what I like to do is take these 10 x's and I'm going to break it up so that I have 2 groups of x's. I want one of these groups to be divisible by 3, and then I can leave my leftovers here. So if I were to take my 10 and just kind of move 1 off to the side, I would be left with 9 x's. I still have 10 in total, they're just in 2 different groups. I have 9 of them over here and 1 on this side. Now when I take that 9 and try to divide by 3, it gives me a nice whole number of 3. These 3 x's are going to go on the outside of the radical. This x here did not divide by 3 nicely. 1 does not divide by 3, so it's going to stay inside of the radical. Okay, so if you ever have an exponent that doesn't divide nicely by that index, break it up so that you have one group that divides nicely and you have one group that does not. You do want to make sure that when you're splitting it up, you are taking out as many x's as possible. The exponents left over on the inside of your radical should never be larger than what's on the outside. For example, I would never want to end up with the cube root of x to the 4th. This exponent is larger than the index, which is a no-no. Okay, we'll take a look at example 3. Okay, very similar problem. This time, hopefully we notice that the index is a 4. So I'm going to start again with trying to use my calculator here. Okay, this time I need to have a square root with a little 4. So what I'm going to do is go to math. I don't want to go down to this 4th one because that had a 3, but on the outside, this 5, I can now scroll over here and change this to a 4. Oops, sorry. And then I can type in 16. Okay, now it does give me 2. I want to show you using this factor tree why it's 2. So I'm going to take 16 and start breaking it down. So I have 4 and 4. 4 times 4 gives me 16. 4s I can break up into 2s. So again, it looks like I have 2 times 2 times 2 times 2. Okay, this time my index was a 4. This means that my prison has a little bit of a higher security. I think of a 4 greater than 3, it's a higher security prison. So to get out of this jail, 4 of the same number would have to group together. Luckily, I have 4 2s, so I can group all of them together. Unfortunately, in that group, only one of the numbers escapes. So this 2 is now outside of the radical. There was a little 3 already outside the radical, so that 3 is going to stay on the outside, and those numbers that have now escaped from jail are going to multiply together. I'm going to take a look at my variables here. So I have x to the 4th, and I know that I'm going to take that exponent and divide by the index. 4 does divide by 4 nicely. It gives me just 1. So that means I have 1x on the outside. Because it divided nicely, I'm not going to have any x's left over inside of that radical. Y to the 8th is next. So I have y to the 8th. And again, I'm trying to divide by that index. 8 does divide by 4 nicely. It gives me 2. So I have 2 y's on the outside. Looks like there is nothing left inside of the radical. Everything escaped from jail. The last thing that I'm going to do here is simplify by actually multiplying these two numbers. So 3 times 2 gives me 6. Then I have my x and y squared. Okay, I do want to point out that it's okay to get answers where everything is outside of the radical. It's totally fine, but it's also fine if you have some numbers and or variables that are left over inside of that radical as well. Okay, let's go ahead and turn our page to look at a few more examples. All right, let's start here with number 1. Number 1 gives me 5 with the square root of 36x to the 10th. One thing I am noticing is that I do not see an index. I don't see a little number outside, so we know that it's always a nice little invisible 2. I'm going to start again with trying that on my calculator. Okay, that is just a regular old square root, so I'm going to second x squared, and I'm typing in 36. Square root of 36 is 6. So I now have a 6 on the outside of my square root. The 5 was already out there, so I'm just going to drop that 5 down, and those two numbers are going to multiply. Looking at my variable, I have x to the 10th. I'm going to take that exponent and divide by the index. 10 does divide by 2 nicely. It gives me 5. So I'm left with x to the 5th power on the outside. Because it divided nicely, there's nothing left inside of that square root. These two numbers are like terms, so they can go ahead and multiply together. 5 times 6 gives me 30, and I'm left with 30x to the 5th. Okay, number 2 gives me another square root. I don't see an index there, so the index is 2. And then I have 12x to the 6th d to the 3rd. I'm going to start with seeing if 12 is a perfect square. So I'm going to second x squared and typing in 12. That gives me a decimal. Don't want decimals for any of these, so we're going to make a factor tree. So I'll take 12 and break it down. You can break it up any way you want. You'll still end up with the same numbers at the end. So I'm going to do 6 and 2. 6 can break up then into 2 and 3. So it looks like here I have 2 2's, so I'm going to write that as 2 times 2, and then I have a 3. I like to put the same numbers together. It helps me figure out if I'm going to have any groups to take out. Because that index was a 2, I'm looking for groups of 2. So it looks like I have 2 2's. Those guys can group together. Unfortunately, only one of them is going to make it out of jail, so I'm going to cross off the other one. This 2 now is on the outside. I'm going to leave a little bit of space here because hopefully some of these variables can escape from the jail, but I'm going to rewrite my radical because this little 3 here did not have a partner. He did not have a buddy. He could not escape from jail, so he's stuck inside. Moving on to my variables, I'm starting with x to the 6th power. I'm going to take that 6 and divide by the index. 6 does divide by 2 nicely. It gives me 3. So I have 3 x's on the outside. No x's left inside because it divided nicely. I have d to the 3rd power. Now 3 will not divide by 2 nicely. So instead, what I'm going to do is take these 3 d's and split them up into 2 groups. So I'm taking the 3, I'm going to split just 1 off to the side by itself. So here's the 1 by itself. And then I still need 3 in total, so I would have 2 left over here. Now this is nice because when I try to divide by 2, 2 does in fact divide by 2. It gives me 1. So this 1d will be outside. You can either write it as d, you could put d to the 1st power, either one would be fine. And there was 1d left over that did not have a partner or a group. It did not divide nicely, so it stays inside of the square root. So this right here would be your final answer. 2x cubed d times the square root of 3d. Okay, let's take a look at number 3. Number 3 gives me the 4th root, the little index is a 4, of 81, a to the 20th, b to the 12th. Now I'm not very good with indexes of 4, so I like to go right to my factor trees. 81, I know, breaks up into 9 times 9. 9 can break up into 3 and 3. And this 9 can break up into 3 and 3. So it looks like I end up with 3 times 3 times 3 times 3. 4 3's all there in a line. To get out of jail, I would need groups of 4. So I'm going to group up my 4 3's. Again, unfortunately, only one of those 3's can escape. I crossed off the other ones. Only this 1 3 gets out of jail. These other 3 just didn't make it, so unfortunately they're not outside, but they are no longer in jail either. Moving on to our variables, I have a to the 20th. I'm dividing that exponent by 4. 20 divides by 4 nicely, gives me 5. So I have 5 a's on the outside with the 3. b to the 12th is next. Again, I'm dividing that 12 by the index, so by 4. 12 divides by 4 nicely, giving me 3. So I have 3 b's on the outside. All of the numbers had a group, and all of my exponents divided nicely, so there is no radical left over. Okay, number 4 gives me the square root of 72, a to the 8th, b to the 5th. I don't think that 72 is a perfect square, but let's go ahead and check. Second x squared, I'm typing in 72. I get a decimal, so that's a no-go. So we can go ahead and break 72 down. Now 72 is a pretty big number, so if you needed to, you could use your calculator. 72 divided by 2 gives me 36, so I can do that. 36 can break up into 6 and 6. And 6, I know, can break up into 3 and 2. Now I do want to point out this is not the only way that you could make your factor tree. So if I had 72 over here, maybe you decided to try 72 divided by 4. Okay, well that works. So I could do 4 and 18. 4 I can break up into 2 and 2. 18, I believe I can divide by 2, gives me 9 and 2. And then 9 I can break up into 3 and 3. So very different trees here, but hopefully you notice that either way we break it down, we're ending up with the same final numbers. Over here I ended up with 3 2s, and then there were 2 3s. Same thing over here, I had 3 2s and 2 3s. So don't stress too much about how you're deciding to break down that factor tree. As long as you're breaking things down completely, you should end up with the same prime factors. Okay, now jumping back over here, I didn't see an index on this one, so I know that it's a nice little invisible 2, which means I'm looking for groups of 2 to escape from the jail. Okay, I had 3 2s here, but I only need groups of 2, so I'm going to group just 2 of them together. I also have a group of 3s, so I can group that together as well. So this is the first time we've seen 2 groups. I'm going to go ahead and cross off one number from each group, and the other number is going to escape from jail. So I now have a 2 on the outside, this 2 here, and this 3 is outside as well. Those numbers are going to multiply, just like we saw back in number 1 when the 5 was already out there. If you have 2 groups escaping, those 2 numbers are going to multiply. If you had 3 groups, you'd have 3 numbers multiplying together on the outside. If you had 4 numbers, you'd have 4 numbers multiplying together on the outside. Okay, this little 2 here did not have a group, so that one is, again, I'm leaving a blank for my variables. That 2 is staying inside of the radical. Looking at variables, we have a to the 8th power. I'm dividing that exponent by the index. 8 divided by 2 works nicely, giving me 4. So I now have 4 a's on the outside. B to the 5th. Well, 5 won't divide by 2, so instead I'll split this up into 2 groups. If I take just 1 away from the 5, I'll be left with a 4 here, which is nice because I think 4 divides by 2 nicely, giving me 2. So again, these 2 b's will be outside, and this 1b here that didn't divide will stay inside. I'm going to go ahead and multiply. So 2 times 3 gives me 6. I have 4 a's, 2 b's, and then I have my square root of 2b. All right, we're going to keep going here. I'm going to take a look at number 5. 5 gives me the cube root of 96, x to the 11th, y to the 15th. So let's check using that calculator, see if the cube root of 96 is a nice number. Remember, to get that cube root, I'm hitting math, and then going down to number 4. Looks like we got a decimal there, so I will have to make a factor tree for 96. Alright, 96 divided by 2 would give me 48. 48, let's try 4. That gives me 4 and 12. 12 I know can break up into 3 and 4. And 4 can break up into 2s. Don't forget about this 4 here. He can also break up into 2s. So in total, I have 1, 2, 3, 4, 5 2s. So I'm going to write 5 2s here. So there's 1, 2, 3, 4, 5. And I have 1, 3. Okay, to get out of jail, these numbers would need to find groups of 3. So we only have 1 3, so unfortunately he's stuck. I have a bunch of 2s, so I'm going to group 3 of them together. I cross off all but 1, and this 2 is going to get out of jail. So I'm going to put that 2 right here outside of the jail. All right, this time I have kind of a bunch of things left over. I have a 2, I have a 2, and a 3. I cannot group those all together in a group because they're not the same number. 2 of them are 2s, but this 3 kind of messes up the game here, so I cannot make that a group of 3. So all of those numbers there are going to stay inside of your radical, and just like we did on the outside, they're going to multiply together. Alright, moving on to variables, I have x to the 11th. Oops. Okay, 11 does not divide by 3. So I'm going to make some groups here. Now, when I go to split these up, my guess is your first instinct is to take 1 and put it off over here like we've been doing, which would leave me 10 on this side. That's still giving me 11, right? 10 plus 1. But does 10 divide by 3? It doesn't. 10 doesn't divide by 3 either. So instead of just moving 1x off to the side, what if we moved 2? If I had 2 x's over here, but I needed 11 in total, I would be left with 9. That one is a little bit better because 9 divides by 3 nicely, giving me 3. So watch out there. You're fine to start with trying to split it up into a group of 1 and a group of however many are left over. But if this first group still does not divide by the index, you might have to move some more variables off to the side. Right, these 2 x's here did not divide nicely, so those 2 x's are going to stay inside of the radical. My last one then is y to the 15th, which I'm dividing 15 by my index. 15 divides by 3 nicely, giving me 5, so I have y to the 5th outside. The last thing that I'll do here is a little bit of simplifying. No like terms on the outside to multiply together, so I can leave all of those. But inside of this radical, I have 2 times 2 times 3. So I'm going to just do that right in my calculator. 2 times 2 times 3 gives me 12. And I have 2 x's in there. Okay, now it is okay that this variable still has an exponent. That 2 is its exponent. That exponent of 2 is smaller than the index, so we're still okay to have those 2 x's inside. Okay, go ahead and pause your video. I want you guys to try the next 5 problems. And then I will show you my work so you can check your answers. All right, let's go through these. For number 6, you could have used your calculator. The square root of 81 is 9. If you made a factor tree, you would end up with 2 9s. You could group them together. Either way, you're going to get 9 on the outside. All of these exponents here dividing by the index of 2, everything divided nicely. So I'm left with just a to the 8th, b to the 10th, c to the 6th, nothing left inside of that radical. Okay, number 7 was a little bit trickier here. I started with typing in the cube root of 27 into my calculator. So math for 27 gave me 3, so that's how I just got this 3 out here. Don't forget there already was a 2 out front, so we are multiplying those numbers. Working with our variables, I took the 12 and divided by 3. That gave me 4. That's why there's 4 y's on the outside nicely. Z to the 7th didn't work out perfect. 7 does not divide by 3, so I split the z's up into 2 groups. I had 1 off to the side and then 6 of them in a group. That part is nice because 6 divides by 3, giving me 2. So there's 2 z's left on the outside. And this 1 z here that did not have a group stays in that radical. Okay, number 8, if you were smart, you would have typed in the cube root of 64. I clearly did not do that. I did all of this work here. So if you went to math 64, it would have just given you 4 right away. I don't know, I wasn't thinking, so I went the long way. I made a big old factor tree for 64, and I ended up getting 6 2's. I was looking for groups of 3 because of this index, so I grouped 3 2's together. That happened twice, so I ended up getting 2 2's on the outside. There was already a 3 out there, so that 3 just dropped right down. Variable-wise, I took the 18 and divided by 3, giving me 6. I took the 12 and divided by 3, giving me 4. In the end here, make sure you type in 3 times 2 times 2 into your calculator so you can get a final answer of 12, b to the 6th, c to the 4th. Okay, number 9. The square root of 18 didn't work out nicely, so I made a factor tree. I ended up getting 1 2 and 2 3's. I grouped together the 3's and crossed one off, so the 1 3 came on the outside. Sorry about that, I just caught an error, so I changed my work real quick. I did still break down the 18. There were 2 3's there, so we grouped them together, crossed one off, and the 1 3 came outside. There was already a 5 outside, so we dropped that down. So the only number left is a 2, so make sure that 2 is inside your square root. A to the 6th, I took the 6th and divided by 2. It worked out nicely, giving me a to the 3rd power. 3 did not divide by 2, so I broke this b up into 2 groups. I had 1 here and 2 off to this side. 2 divided by 2 gives me 1, so I had 1b outside. And this little guy that did not have a partner or a group, didn't divide nicely, stays inside. Similar idea with c to the 5th. I took c to the 5th, that didn't divide by 2, so I broke it up into c to the 4th and 1c here. 4 divided by 2 gives me 2 c's on the outside, and 1c left over stays inside. Last step, multiplying that 5 and 3 on the outside for like terms, giving you 15. And our last one, number 10, a little bit of an easier one to end with. I took 16 and broke it down. Regardless of how you make your factor tree, you should end up with 4 2's being multiplied together. We're looking for groups of 4, so I grouped all 4 together. Only one of those 2's makes it out. The other 3 don't make it. Variable-wise, 8 divided by the index of 4 gave me 2, so I ended up with just a 2x squared.